Inlays is a process of fitting one part within another. When using a CNC to machine a part to fit it into another, you cannot get into the corners as shown in the area clearance video. This is because of the radius of the tool that you are using. The mating piece would not have the same problem on the same corners, so when that part was fitted into the pocket, it wouldn't fit together. You could solve this by actually drawing the radius on each corner manually, but the inlay toolpath does this automatically for you. Here you can see a table that I want to make and have the fleur-de-lis area in the centre as a different material, so I'm going to do this as an inlay. The inlay toolpath is located below fluting under 2D toolpaths. When you select it, it will open a dialog called Inlay Wizard, which asks you whether you would like to do a female or a male part and what type. For this example, I'm going to create firstly a female pocket. The actual toolpath dialog is very much similar to the other toolpaths and can be treated much like creating an area clearance. Select the finish depth and the finishing tool. Make sure that you make a note of the finishing tool though, because you will need to use the same tool when you create the male insert to fit into the pocket in order to match. You can also use a roughing tool to get rid of most of the material prior to finishing. Again, you can choose the strategy and select Calculate Now. I can now simulate the toolpath, and if I zoom in on one of the internal corners, we can see that the tool can't physically get right into the corner. Now let's create another inlay, this time the male insert to fit into the pocket. I'm going to just choose to do a straight insert. Now this is a very simple profile dialog toolpath. A depth needs to be entered. Remember, the pocket is 3mm deep, so if I am using material larger than 3mm, it will stick above the table. Also, make sure to change the material thickness. The allowance lets you enter a figure, and this can be a negative figure if you want to take a little bit more off the material of the male in order to fit into the pocket, rather than it being size on size, which definitely would not fit. You can also do this on the pocket if you wish to do so. Choose your tool, remember to use the same tool as the pocket, and then calculate. Now if I simulate this, you can see that it has basically cut the parts out, but if I zoom into what would be one of the internal corners on the pocket, where the tool couldn't get in, you can see that the corner has automatically been rounded off, meaning that the piece will fit into the pocket without having to manually sort out the corners for fitting.